This is part B and C of question, what are we up to now? Question 4. And here we have the graph of 2 sine x already drawn for us. And we're also given the function h of x, which is 1/3 sine 3x. And on the same set of axes, we have to sketch the graph of h of x. So you shouldn't need your CAS for this. You can look at h of x and notice that your amplitude is 1/3, which they've marked conveniently for you on the graph, and your period is 2 pi on 3. So every 2/3 of pi, we're going to get a cycle, or the graph will repeat. So we can even mark out our intercepts at every 1/3 of pi. There's 1/3. There's 2/3, 3/3, 4/3, 5/3, 6/3. We notice that there's no negative sign there, so it's a positive shape, and we need to observe that amplitude. So let's do our sketch carefully. There's 1 cycle, 2 cycles, and that's 3 cycles. And that makes sense. We expect 3 cycles by comparing the periods of these two functions. Right, so that's our sketch done. Now we have to state the transformations that take us from f of x to h of x. So let's just label those. This is f of x. There's h of x. How do we transform f of x into h of x? Well, the first thing that happens is we're getting squashed. They're both dilations. We're going that way. We're getting squished that way. Now, how do we describe this? Well, they're both dilations. So the first one we're going to describe as a dilation by a factor of what's happening. We're going from 2 to 1/3. So we're going from 2 times some dilation factor to get to 1/3. What's the dilation factor? Well, it's going to be 1/6. So it's a dilation by a factor of 1/6 away from the x-axis. And you might say, but hang on, we're getting closer to the x-axis. Yes, we are getting closer to the x-axis. That's why this is a value smaller than 1, because it's doing the opposite. So dilation by a factor of 1/6 from the x-axis. And we're also getting squished in this way. Now we have to describe that in terms of the y-axis. So we're going from x here to 3x. What does that mean in terms of dilation? Well, we know it's a dilation. This time it's by a factor of, well, let's have a look. We have 1 times some dilation factor, which is needing to get us to, now be careful here, because we have to take the reciprocal because it's next to x. So we want 1 times some dilation factor to get us to 1/3. So the dilation factor must be 1/3. So dilation by a factor of 1/3 from the y-axis. Dilations are particularly tricky to get your head around, especially in terms of the y-axis. I find students don't have too many issues when it's away from the x-axis, because everything's flipped around and reversed for the y-axis. You have to watch that one very carefully.